Welcome everyone to this new episode in this series of design patterns. The design pattern which I have shortlisted for today's session is the decorator design pattern, and it falls under the structural pattern category. What this decorator design pattern does is it adds extra functionalities to an existing object without changing the behavior of the existing object. So let's take example of buffered reader to understand this concept. So how do we create an object of buffered reader? So we create buffered reader, object BR is new buffered reader. Then in this we have new input stream reader and then system.in. So this is a hierarchy of classes, one after the other. So system.in is the keyboard. So data is fetched from the keyboard, and we know that each keystroke has a ASCII value or some byte value associated with it. So capital A has a byte value of 65 and small a has a byte value of 97, and so on and so forth. So data from this keyboard is then sent to the input stream reader. So in the core is your system.in, which is the keyboard. Data from the keyboard is fetched in the form of bytes. So if I want to type ABC, small capital ABC, so the input stream is a bridge which will convert the bytes to characters. So if the user has typed ABC, the input stream reader will read it as 65, 66, 67, capital A, capital B, capital C. And then depending on the character set which we are using, it will convert it to the corresponding character value. So 66 will be converted to capital A, 67 will be converted to capital B, and 68 will be converted to capital C. This conversion is done by the input stream, and then this input stream hands the data to the buffered reader. Now this buffered reader converts it in the form of a string, and then which will be stored in the string variable. So at the core is your system.in, and above that is a layer of input stream, above that is a layer of buffered reader. So in this decorator pattern, we can think of this core as your decorated object, the object which I am going to decorate. So if I have a gift, so if I have a, let's say if I have a pen and I want to gift my friend this pen, so I will not gift it as it is. I will wrap it in some nice packing in a wrapper, right? So this is my gift, and I have wrapped this gift in a wrapper, and if I want to decorate it further, I will add more decoration to it. So I can add more decoration to it to decorate it further. So I can add more decoration to it. So if you look at the core is your gift, at the core is your gift, and then you can wrap the gift in different wrappers. So this is your wrapper 1, and this is your wrapper 2. So here you can think of system.in as your gift, and new input stream is adding extra functionalities to it, and buffer reader is adding extra functionalities to it. New input stream is converting the bytes to characters, and then buffer reader is converting those individual characters to string. So extra functionalities is being added. This is what I had mentioned over here. The decorator design pattern allows us to dynamically add functionalities and behavior to an object without affecting the behavior of the existing object. So it will keep on adding functionalities to this without affecting the functionality of the keyboard. Okay. Now this is when we will do the practical, then I'll show you what is this. So over here, so in this decorated design pattern, at the core we have the decorated object. What do we have? At the core we have the this you can call as the decorated object, the object which I am going to decorate. So what are we decorating over here? The gift, the pen, right? The pen is the object which we are decorating. So at the core you have the object you wish to decorate. That is called as decorated. It is called as what? Decorated. And on top of that we have different decorators. So we have decorator 1 and decorator 2, which I will use to decorate this object. Clear? So let's, okay, it will use is a as well as has a relationship. Is a is inheritance and has a is composition. I have a separate video on this. You can, I'll provide the link in the description so you can watch this video, relationship between classes. The video titled relationship between classes, so will help you understand this concept better. Now coming back to the UML of the decorator design pattern. So what I'll do is, first thing first, okay, the use case I am using over here is of a tennis court. So we have a court, lawn tennis, Roger Federer, Rafael Nadal, Sania Mirza. So tennis is played on different surfaces. So the two surfaces which I am taking in this example is your hard court. You can also call it as clay court. So it is also called as clay court and grass court. So the turf is made of, is of grass that is called as grass court. So Wimbledon is played on grass court, and your US Open and Australian Open. US Open and Australian Open is played on hard court. So these are two types of surfaces on which lawn tennis can be played. So I have a I court. So this is an interface by the name I court, and this will just provide the basic functionalities of what a court should provide. Abstract, so it is an interface, so it has one abstract method by the name get base price. It has just one abstract method by the name get base price, and these are two concrete classes. So hard court is a concrete class which is implementing this interface I court, and grass court is a concrete class which is implementing this interface I court. So this is my component, this is my abstract component. So this is my, which I want to decorate this. So this is my decorated, this is my gift, this is my abstract form of the gift. This is a abstract form of the gift which I wish to decorate. So I court is my abstract form. Now we have two concrete classes. So I have hard court which implements I court and grass court which implements I court. So hard court will give the body to get base price. So the base price of hard court is 100 and the base price of grass court is 200. So understood so far? So we have a interface for the component, for the decorated which we wish to decorate, and we have two concrete classes over here which will implement this interface. So we have two concrete classes. So I will be decorating these two objects. So I'll be decorating object of hard court and I'll be decorating object of grass court. Now with what will I be decorating it? Now if someone has subscribed for a hard court but he has no rackets and no balls to play with, so he will say, okay, I also want a ball. So I have booked a hard court, but I also need some balls to play with it, to play tennis. So he or she will subscribe for a ball pack, or if they also want, we also give a racket, or we also give umpire. So these are different toppings, or you can say these are different decoration we will do on this coat. So we will decorate the hard coat with, so if someone says I want a ball pack, we will provide a ball pack, but we will charge some fees for it. So we will charge a fees of 10 rupees. So along with the coat charges, so if he has selected hard coat and also wants a ball pack, so we will get the base price of the hard coat, which is how much? 100, plus for the racket we'll charge 10. So hard coat plus racket will charge how much? So hard coat plus racket will be charged 110. Okay, if he wants hard coat plus racket, okay, sorry, hard coat plus ball pack 110. Okay, if he wants hard coat plus ball pack plus racket, so that will be how much? 100 plus 10 plus 20, that will be 130. And the umpire will charge plus 30 extra. So if he wants hard coat plus ball pack plus racket plus umpire, so we are decorating the coat now. If you see, the hard coat over here is your decorated. So this is your object, and these are the level of decoration I am adding to it. The ball pack, the racket, the umpire. So if you see in the example below, so this is your hard coat is your object, which will return you 100. So I am adding it with decorator. So if I add a ball pack, it will add the base price plus 10. So hard coat plus ball pack is how much? Total 110. Hard coat plus ball pack plus racket will be how much? 130. So this is my decorated, and the ball pack and racket are my decorators. So we will have an interface for the decorated and concrete class for the decorated, and similarly we will have a abstract class for the decorators also. This is an abstract class. You cannot use the interface over here because this is also implementing this. So how the concrete class are implementing the component, the iCode interface. So this abstract class, which is the service decorator, it also implements the component. So it is also is a relationship over here. Is a relationship over here. So as mentioned over here, uses inheritance also is a relationship, and plus it has a object of the iCode over here. It will have a object of the iCode of the object which it wants to decorate. So the iCode, so we have a protected iCode my code object over here. So this is a has a relationship. This is a has a relationship. So when we have an object of one class into another class, is a has a relationship, and when we inherit, it is a relationship. So we are having both over here, has a and is a. Now this is the abstract class of service decorator. So now we have concrete classes for the decorator also. So concrete classes for the decorated over here, hard coat, grass coat, and concrete classes for the decorator also. So we have ball pack and racket. So ball pack extends service decorator and racket extends service decorator, and we can also have umpire extends service decorator, and we can have n number of services over here. So we can have n number of services over here. So if they want a DJ, we can provide the DJ. If they want a photographer, we can provide with a photographer also. Blah 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 blah. We can add n number of services. So I have done 3 services. So ball pack will extend service decorator, racket will extend service decorator, umpire will extend service decorator, DJ will extend service decorator, photographer will extend service decorator, and this service decorator will implement I code. We have to use the is a relationship. And now in this, so now when it extends, now when ball pack extends service decorator, the protected data is inherited. So here you will have I code coming in. So ball pack will have protected. Understand this concept, guys. We'll have protected I code, and the variable name is my code. So my code reference has come into ball pack class because it is extending this service decorator. Now in this, first thing first, you have to create a constructor. You have to create a constructor. So, and that constructor I will use to initialize my code. So whenever I create an object of ball pack, I will pass a type of I code to it. So either I will pass hard code object or I will pass a grass code object. That object which I pass will go in X, and from X it will go in my code over here. And using this my code, then I will call the get base, and as it is now, see the flow. Service decorator is inheriting from this. So get base price has also come over here. So get base price, because of the inheritance, has come over here. So even though if I am not writing anything, it is still over here. And then as this is a concrete class, so it has to override all the abstract methods. So it has to give body to get base price also over here like this. Am I understood? And what it will do is, it will fetch the original price of the original object and add the extra functionality what it wants to add. So whatever extra functionality it wants to add, it will add over here. Like this, I can create n number of decorator concrete classes also. And then I'll have my main. So in main, first I'll create the object which I wish to decorate. So if I want to decorate the hard code, so I will create an object of hard code, and as hard code is of type I code, so I can use a reference of I code. So I code US open, new hard code, I code Wimbledon, new grass code. Okay, and now I will create a service decorator object. So I can use a reference of service decorator. So if I want to create an object of ball pack, so I can say service decorator balls, new ball pack, and I have to pass object of I code. So I can pass object of so I'll pass hard US open over here. So object of US open has been passed over here, and now balls plus US open is how much? US open is 100 and ball is 10. So you should give me. So now when I call the function get base price, it should print me 110. It should print me 110. Or you can do it like this also. If I want to do it in this way, the decorated object, then one decorator, then second decorator, as I mentioned over here, decorator 1, decorator 2. So what you can do is US open to new umpire, then this to new racket, and this to new ball pack, like how we have done over here. New buffered reader, new input stream reader. So you can say service decorator A, I didn't have space over there, so I can do. So SD, give any name to it, A equals to new ball pack, new racket, new umpire. So I am decorating, these are my decorators, and I am decorating which object? I am decorating US open, which is of type I quote. So now what will be, so now, and now using A, if I say get base price, it will display me US Open will return 100, right? So the core will return you 100 plus umpire was 30, right? Racket was 20 and ball pack was 10. So 100 plus 30 plus 20 plus 10, and so now when I say A dot get base price will display me 160, because what am I doing over here? The my quote object, which is US Open, get the base price, that it will get the base price from here, the base price of the US object 100. Along with that, keep on adding the extra functionalities. It is more like recursion. So for ball pack it will add 10, for racket it will add 20, and for umpire it will add 30. So this is the architecture of my program. Now let's try to code this. So I have done the coding. So first we will create a iQuote interface which will have one abstract method called as get base price. So this is my iQuote, which has one, as it is an interface, no need to write abstract because everything in the interface is abstract. So get base price, which will return me type integer, because it is returning me 100, 110, 120. Okay. Now we'll have two concrete classes which implement this. So hard code implements iQuote and grass code implements iQuote. So it is the responsibility of hard code and iQuote to give body to get base price. So your hard code implements code, and if we are overriding the get base price, so hard code will return 100 and grass code will return 200. So these are my decorated objects, object which I want to decorate. Okay. Now I will create a abstract class. Why can't I create an interface over here? Why can't I create an interface over here? Interface is not allowed. Why not allowed? Because interface cannot extend. Interface, you cannot create an interface over here because this is an abstract class service decorator. Okay, because we can place a constructor also over here. If we wish, we can place a constructor also over here. So we can have a service decorator constructor over here also, and you cannot have any constructor in interface. That's why we will not use an interface over here. So we will keep this as abstract class. So this abstract class will also implements this iQuote, like how these decorated objects concrete classes are doing. So abstract class also implements iQuote. So using this implement, this get base price comes to the abstract class also. So this is a service decorator which implements iQuote. So by using this implements, this get base price function comes into this service decorator. Plus this is the, so this implements is a relationship, and now we want to have a has a relationship. So we will create a object of either hard code or grass code. So we can directly refer to the iQuote. So we will have a iQuote reference over here as my code. Okay. So now your service decorator has iQuote object, plus with from the inheritance it has a get base, it has the get base price. So we don't have to write it over here, we just have to visualize this. So whichever class is, this is the abstract class extending the service decorator, has to initialize my quote object and has to override the get base price method, right? So we have ball pack which extends service decorator. So ball pack which will initialize my code, and ballpark will override the get base price. So we'll get the base price from the my code object, and we will add the extra functionalities over here. So this is your ballpark, this is for the racket, and this is for the umpire. And now if you go to the client program, decorator demo, so we have iCode object, US Open, and Wimbledon as a grass court. And now service decorator balls is new ball pack. I'm just decorating the US Open with ball pack. And now if from balls, if I call get base price, US Open plus ball is how much? 110. US Open with racket is 100 plus 100 plus 10 is 110. 100 plus 20 is, and 100 plus 30, right? Now if I wish to decorate it with all three, so what I can do is service decorator object, I made a new ball pack, new racket, new umpire, and this is the decorated object, US Open, right? So US Open with umpire, with racket, with ball pack will be how much? 160. So the output of this program will be 110, 120, 130 and 160. So let's try to compile them. Java C, and Java decorator pattern demo. Yeah, 110, 20, 30, and if you should decorate all, is this 160. So this is your decorator pattern. So now if we go back over here to the theory part, using inheritance as well as has a decorator pattern creates a decorator class. Okay, the decorator classes were ball pack, racket and umpire, which wrap the original class. So the original class was hard court or your grass court, and supply additional functionality. So we were supplying additional functionality to hard court and grass court by keeping the method signatures unchanged. Decorator design pattern are mostly used for applying single responsibility principle. This is a design technique, single responsibility principle. And now what was the procedure? So first you create an interface having your decorated object. So we had created iCode. Then you create concrete classes to implement the decorated object. So we had hard court, grass court, and then create an abstract decorator. So we had created what? Service decorator abstract class. This one over here, service decorated. And now we need to create concrete classes for this decorator. So for that we had created ball pack, racket and umpire. And now use the concrete decorator classes. Now use the ball pack, racket and umpire to decorate the interface object, to decorate the iCode interface objects.